Hi everyone, welcome to my channel Talk and Do Physics. In today's lesson, we are going to dive into the objective questions from WAEC past question number 49. And the question goes thus: an electron jumps from one energy level to another in an atom, radiating 4.5 times 10 raised to the power 19 joules per second. Determine the wavelength of the radiation. When you are given something like this and the Planck constant is 6.6 times 10 raised to the power minus 34 joules, and C is what? 30 times 10 raised to the power 8 meter per second. When you have these questions, don't allow anything to intimidate you. This is just a question. Once you just plug the formula, just bring out the formula, you get to the right answer. So as you are watching me, remember to share and subscribe. Click at the bottom below, and this will interest me to do more interesting video. Let us use the formula to see if we'll arrive at the answer. What is step 1? In this case, the formula is what? Planck constant. We know the formula is energy equals to what? Planck constant C all over wavelength. That is the formula that we are going to use to solve it. So let's dive into it. Is it energy given? You check which one is given. You can see here we have a Planck constant here. This is H. That one is given. Correct. And we see C. Oh, C is given, which is C is here. That is given. And what next? We are asked to calculate what? We are asked what next is given? Yes, the energy is given, because the energy from one point that the electrons jump from one point to the another is 4.5. Very good. So what next? We are done with solving the problem. So we are going to do what? Change of subject formula. So we have E wavelength equals to Hc. So we are going to divide both sides by what? Divide both sides by the energy, so that we can be able to get the wavelength of the radiating particles. So now wavelength equals to what? A lambda equals to Hc all over E. That's the formula that we are going to use. So now we are going to substitute this value into this formula. So let's dive into it. That is, we have here wavelength. Very good. What is the Planck constant? 6.6 times 10 raised to the power 34 joules. Very good. Then what is the next one? C is what? 30 times 30 times 10 raised to the power 8 meter per second. Very good. All over what? The energy, 4.5 times 10 raised to the power 19. I told you, when you are solving this, you are going to select the raised to power to one side and also solve the main decimal point one side. So we now have here, we say wavelength equals to 6.6 times 30, very good, all over 4.5. Then you now say times 10 raised to power 34. 30, what do we have in 34? 34 minus, very good, 8, then minus what? 19. So when you have this, this will give us, so 6.6 times 30, all of divide by 4.5. What will it give it to you? This will give you what? Wavelength equals to 4.4. Then you now say 10 raised to power 34. Very good. Minus 8. Good. Minus 19. This gives you what? Times 10 raised to power minus 7 meter. So the answer is 4.4 times 10 raised to power 7 meter. Do we have it in the option? Let's check. 4.4 times 10 raised to power 7. This is the right answer. So as you are watching me, the answer is D. Very simple. As you are watching me, remember to share, subscribe, click at the button below, and this will interest me to do more interesting video. Thank you.